Hey everybody, welcome Smash Team and others to the Daily Space Weather. The channel's future is so bright, we've got to wear shades here at the Smash News Network, least busted name in news. Here's some imagery of the sun from the Solar Dynamics Observatory in ionized iron. Only one sunspot group and a big coronal hole in the southern hemisphere. We'll get to it. It's a well-defined coronal hole that's so well-defined it's even visible in ionized helium 304 angstroms. How about the colorized magnetogram? Again, only one sunspot group. Sunspot 2894 has been degrading since yesterday. Here's 171 and 304 angstroms combined. Ionized iron and helium in one set of images. Radio flux has dropped all the way down to 81. And for you new viewers, the radio flux is a proportional data set to sunspot number. Here they are together. The red line is the sunspot number. The black line is the radio flux over the past year. Space Weather Enthusiast dashboard indicating some geomagnetic unrest coming from a coronal hole about to strike late in the day on November 16th. So late in the day on the 15th, we're expecting a big uptick in solar wind density from that very well-defined South Pole-oriented coronal hole system. As you can see here on the Enlil prediction, an uptick expected here about midday on the 15th in the density, and then an uptick late in the day on the 15th, early on the 16th for the solar wind speed. Again, you can find that yourself on the Space Weather Enthusiast dashboard if you like. Let's take a brief look at global seismicity. There's a magnitude 7 earthquake drought currently occurring, folks. So yesterday we saw very low levels of activity as far as global seismicity goes. Today a little bit more activity. However, keep in mind some of these could be foreshocks. If you're in an earthquake-prone zone, please have a plan. Know what buildings might collapse. An odd earthquake here in Western Australia is the first one we'll report. That one was at 13:05 yesterday on the 13th. Indonesia saw a deep quake about 40 minutes later. Not very far away there. And then we saw a 5.5 here near Fiji and Tonga. And another 5.5 only 2 minutes later. A large portion of the way around the world there in the mid-Atlantic ridge part of the southern Atlantic Ocean area there, where the American plate and the African plate come together, the plate boundary between those two, around the Tropic of Capricorn there. Again, some of these quakes could be foreshocks, folks. And it seems like the best way to forecast earthquakes is through basic statistical analysis. Very deep quake at the Fiji Islands also happened, a 4.9 at over 500 kilometers depth there. And a 5.2 aftershock there in the mid-Atlantic ridge. South Sandwich Islands continue to shake with another 5.1. And yet another another aftershock there at the southern mid-Atlantic ridge. So again, folks, keep in mind any of these quakes could be foreshocks. Please have an earthquake plan if you're in an earthquake-prone zone. Next, volcanoes. La Palma has been erupting pretty consistently here over the past several days. Still explosive in its nature. It's producing a 8,000-foot plume of volcanic ash. Don't fly your hang glider over the caldera. It could be an unhealthful day for hang gliding. Karimsky, volcanic ash not identifiable in satellite imagery. Don't assume it's not erupting. That's located on the Kamchatka Peninsula. Suminose Jima, flight level 070. It's producing a 7,000-foot plume of volcanic ash. Semeru, located in East Java, Indonesia, exploding most likely here with a 14,000-foot ash plume. And another one showing up here on the list. I've never heard of it before. It's Fernandina, located in the Galapagos Islands of Ecuador. So there's been some uplifting and some other deformation. The ground rising and sinking around there, suggesting it may be about to erupt. Deformation data suggested that the magma may be accumulated at 2 kilometers shallow or deep magma reservoir located 4.5 kilometers under the surface? Is there a volcano about to erupt in the Galapagos? Leave us a comment. Let us know what you think. Popocatépetl exploding. Central Mexico is where that's located. It's producing a 19,000-foot plume of ash, fertilizing the nation of Mexico. Fuego exploding. 15,000-foot ash plume from Fuego in Guatemala. Sangay volcanic ash not observed. Don't square dance the caldera. It could be erupting. It could be because of cloudy images in the satellite data. Revenador exploding. That's located in Ecuador. It's producing a 15,000-foot plume of volcanic ash. Continuous ash emissions from Sabancaya are a reminder to not pole vault the caldera. And here's a reminder from me to please visit the links below the video. Please support the channel if you would appreciate these videos and you'd appreciate them to continue existing. We need your support because the channel is in danger constantly of going out of existence. Today's featured product is the Smash Team. And this design is a little bit different than what you'll be able to purchase on the links because it's for paid up members only, but it's very similar to a design that we do offer. In any case, please don't pole vault the caldera. Please make Earth not suck again. It's up to you, individuals. And there's the featured product design there. It's the Smash Team. The color scheme is a little bit different, as the one I'm wearing is for paid up annual subscription members only. smashomash.com/smashteam. You can find the merch link there, as well as on the homepage at smashomash.com. In 2018, a crack YouTube unit was sent to social media prison for a crime we didn't commit. We promptly escaped a maximum security algorithmic social media stockade into the internet underground where we survive as producers of fortune. If you have a problem, if no one else can help, and if you can find the content, maybe you can hire the Smash Team. Again, links below the video about all of this stuff. Visit our links, support our channel, become a member of the Smash Team. We've replaced Patreon with something superior, the Smash Team. So welcome to the Neo Renaissance. We also have a forum. Maybe check that out if you've got something you're interested in posting about, whether it comes to the sun or general science or geophysics or just general posts. smAsho Forum is alt tech. You won't be censored as long as you stay within the confines of the law. Yes, we won't censor you, folks. If you make a fool of yourself, keep in mind, we won't censor you. Next, let's look at magnetic data. There's lots of it, although not a lot going on the sun at the moment. Here are the measurements over the past 3 days from the GOES 16 and 17. Nothing to write home about there. Earth is in a South Pole current sheet. No changes forecasted to come in that in the immediate future. That's the top view ecliptic plane field plot showing you the polarity of the plasma in the current sheet. So this gives us all kinds of insight into solar activity. Keep in mind the data is 1 hour and 46 minutes old when we recorded the video. Next, as we do daily, here's the line of sight ecliptic plane field plot. It's the same data essentially, just from Earth's perspective. Again, no changes expected to come here soon. Keep in mind that data, once again, is nearly 2 hours old, and the magnetic environment can suddenly change. Our regular viewers are well aware that sunspots can suddenly form. Check out the coronal hole systems in the southern hemisphere in red. Those will be providing some possible geomagnetic unrest in the coming days. So here's 193 angstroms. Very well-defined coronal hole down here in the southern hemisphere, and another one rotating in. They're both South Pole oriented. Here's a close-up of the southern hemisphere in that wavelength. Spectacular imagery there of a coronal hole. And what's interesting about coronal holes, folks, is that you're looking at ionized iron, which means there's a very low amount of ionized iron in that area. If you look at that in in hydrogen alpha, that will look completely flat. An indication that chemistry matters, and what molecules are where on the sun is super important. Studying the location of coronal holes tells us what's going on with the solar polar field reversal process, which is a process I'll be explaining in a paper soon, as I believe I've determined a plausible mechanism driving the solar sunspot cycles, which are driven by the solar polar field reversal process. Likelihood of major flares is quite low, and we've reduced our coronal mass ejection watch to a nothing. Sunspot 2895 is going to lose its name today because it is no longer possessing umbra. It's going to be listed as decayed to plage. 2894 remains a sunspot, although it is also degrading. No major flares over the past 3 days. There was a C-class intensification. I consider major flares M and X-class flares only. They're capable of producing radio blackouts. C-class flares, not really. No spikes in the proton flux. No relativistic particles striking Earth recently. That's a 3-day chart, by the way. Next, the real-time solar wind. We have seen a minor intensification here in the solar wind density. Currently just under 12 protons per cubic centimeter. Solar wind velocity, only a little over 300 kilometers per second. So a very slow and moderately dense solar wind. At the moment, KP index is at 1. And for you new viewers, the KP index is a measurement of global geomagnetism. Speaking of geomagnetism, here is the Geospace Magnetosphere movie over the past 4 hours. And with the fairly homogeneous solar wind we've seen over the past 4 hours, not expecting major changes in that. Fairly steady magnetohydrodynamic pressure modeled here in nanopascals. This model is nanotesla. This is magnetic flux density. The last was magnetohydrodynamic pressure. And this is based on geospace delta B, ground magnetic perturbations to Earth's B field at the ground level. Since there's a polar excursion going on, we show it daily. Maybe it makes you less frightened of it. Maybe it makes you more frightened of it. Let me know what you think of it in the comments. Are you frightened of the polar excursion? I think it's funny. Next, a diagram of the solar system. If you're wondering where stuff is, oh my God, Earth and the Sun and Mercury and Mars are practically in a row here, and everybody knows that the only thing scarier than triangles and squares and rhombuses and trapezoids and things like that, the only thing scarier than that in space is a straight line. And oh my God, stop the presses, there's a straight line in the solar system. Pardon my sarcasm. There's where things will be in a week, God willing. That's your 1 week solar system forecast. Next, a star chart, and you can see there Mars and Mercury rising ahead of the Sun. Oh my God, it's a straight line. It's very frightening. The yellow line is the ecliptic, the blue line is the galactic plane. And we've actually drawn in the celestial sphere here. So the center of this grid pattern, that is the celestial North Pole, the location of the North Pole star, the celestial pole star Polaris. And if you advance this, actually, the other stars are all orbiting around that location, the celestial pole. I'll just advance this just to demonstrate briefly. If you click Animate, and you can see how Polaris stays stationary and all the rest of the stars rotate around Polaris. Next, and just to reiterate, we've shut down our coronal mass ejection watch. Here's the view from Lagrange point 5 and Lagrange point 1, the location of stereo A and the LASCO C3 coronagraphs. Stereo A on the left. This is Mercury up here, by the way. And the LASCO C3 on the right. No coronal mass ejection showing up in coronagraph imagery. Today's cosmology segment's going to be very brief. How do you identify that light in the sky? Are you wondering? Is it really big? Is it like the size of your thumb on an outstretched hand? Well, if it is, that's really big. It's either the sun or the moon. Is it burning your retinas? If not, it's probably the sun. I mean, if it is, it's probably the sun. If not, it's probably the moon. Now, if it's moving and twinkling and kind of fuzzy and attached to a boat, it's probably a masthead light. But if it's not attached to a boat, it might be a planet. Anyway, check out this if you like. If you're having trouble identifying things in the night sky, apod.nasa.gov can help you out. Yeah, apod.nasa.gov, the astronomy picture of the day. Is it really big? No. Is it moving? Yes. Is it moving so quickly you almost missed it? Yes. Is it extra super bright? Yes. Did it end in a dramatic explosion? Yes. Then it's a bolide. No? Then it's a fireball. That's today's cosmology segment. Check our playlists for more. YouTube.com/smAsho/playlists. No charging hazards whatsoever. We've been seeing some pretty high levels of electron flux, though. Here's the 1-year chart from Solon.info. Here's the 3-day chart, and we're just moving into warning levels for the GO-16. Particle density at 10 to the third, otherwise known as 1,000, which coincides with 1,000 pulse flux units in the NOAA alerts. Just moving into alert territory. We may see some problems with that, but I don't really expect a major uptick in electron flux, and neither does NOAA. There's the forecast from NOAA. That's the green boxes. The yellow diamonds are not lucky charms. Those are the observations. Here's a diagram of Earth Van Allen belts. Feel free to pause the video. Here's the total electron content forecast. Continued GPS errors unexpectedly occurring over places like the southern Indian Ocean and North America. Total electron content shows you the total electron content all the way from a GPS satellite to your handset next to the Ionosphere layer located at 300 kilometers of altitude. Here's the vibrational frequency of the ionosphere. And we're seeing anomalies once again, certainly in the southern hemisphere. And of course, in spring southern hemisphere, you're going to see higher frequencies down there than up in the north. You'll see more low frequency anomalies in the north as winter approaches. And I can't wait for the solstice. I love when the sun gets low in the sky and it gets crazy cold. It's exciting stuff. I like it. Next, the anomalygram. That was the ionogram. Here's the anomalygram, and you can see those low-frequency anomalies in the northern hemisphere. More high-frequency anomalies in the southern hemisphere. It's what you would expect as winter approaches here and southern approaches from under. Shout out to our viewers from under. I mean from under the equator, by the way. And we got a number of low-frequency anomalies occurring there. One south of Africa, mainly in the southern Atlantic Ocean, and one near India and Southeast Asia. There's the ionogram, and there is the anomalygram. It's showing you anomaly in megahertz from the 30-day median. And here come our bonus features. Let's do it. The first is the Cerro Tololo, Chile, the ground-based solar observatory in Chile. Looking at 6,562.8 angstroms, hydrogen alpha. And as we said earlier in the video, if you look down here where this well-defined coronal hole is, it doesn't show up at all in hydrogen alpha. It's perfectly flat, an indication that chemistry matters. The location of iron ions and helium ions and carbon ions and so on the surface of the sun, there are a bunch of heavy elements out there. There's some latest imagery from Cerro Tololo in Chile. This data only 3 minutes old from when we made the video. Next, your latest intensitygram and solar magnetogram. We show you the refresh so you know it's the latest. There's 2894 now having a plasma bridge going across the middle of it. Otherwise, no named group. Oh, wait, we've got a new sunspot rising. There it is. Check it out. It's a new alpha class currently sunspot. There's 2894's fields, not particularly complex, not likely to produce major flares. That new sunspot, 2896, I want to say it is. Alpha class, not likely of producing major flares. Here's the GO-16 SUVI imagery. So yeah, we won't be dropping down to 0 sunspots as there's a new one risen in the southeastern limb. Here's 171 angstroms, and we'll show you a close-up of sunspot 2894 to close things out. Once again, congratulations on realizing we exist, and may that solar wind be at your back.